All right, so here we are in chapter 8. Chapter 8 is about doing the same trig stuff, but with triangles that are not right triangles, because we did all this work with sine, cosine, tangent, cosecant, cotangent, and cosecant. I think that's all of them. But it's a bunch of hooey unless it works with like lots more triangles. And so that's what we're going to try to do here. Get to the really important thing, which is this, the law of sines. So the sine of some angle over its side is equal to the sine of a different angle over its side. And you can even do the same thing with the third angle in its side. Now, we're only ever going to use like two of these things. So like we might use like these two, or maybe we'll use these two, or maybe we'll use the two on the ends. But we're never going to use all three for one problem. So let's try it out. So here I've got a triangle. It's not a right triangle. That's okay. We can use the law of sines in order to figure out things that we're missing. The one I'm going to start with is the easy one, and I'm trying to find the thing that's easiest. The thing I think will be really easy to find is y, because we know two of our angles in our triangle, and we just need to find the third. If you know two and you need to find the third, you just subtract them from 180. Uh-oh, that's going to turn everything blue. I don't want to do that. Can you not be blue anymore, please? Please and thank you. I know it's really hard to undo things, but you can do it. I believe in you. Good job. So in order to find what gamma is, we just need to do 180 minus those two other angles, the 43 degrees and the 105 degrees. You would subtract those in your calculator, 180 minus 43 minus 105. I've got a little cheat sheet up above there, so I'm going to tell you it's 32, just to kind of like save us a little time. You can type it in your calculator if you'd like. So we know what gamma is. It's 32 degrees. Ace. Now we need to find our other pieces. So what we're first looking for is an angle and a matching side that we know. And there is an angle and a matching side that we know right now. And that's going to be the key to unlocking everything. We know what beta is, and we've got beta's matching side. So that's telling us we're set. We can do our law of sines. As long as we have other pieces, we'll be okay. But we're going to keep using that over and over for this same triangle. We're going to do the sine of that angle for beta over its side, which is 30. And we've got to find A and C yet. So to find A or C, it doesn't really matter which one you need to look for first. Let's do A. Let's work alphabetically. So we would grab its angle, which is 105 degrees, over its matching side, A. And if we solve this proportion, we'll be all set. We'll be able to figure out what A is. So we could cross multiply. We've got A sine of 43. I know I'm cross multiplying, but it's nice in this one. I really hate cross multiplying, but what are you going to do? Then we need to get rid of the sine of 43. So we're going to divide both sides by the sine of 43. And so A equals 30 times the sine of 105 divided by the sine of 43. I need to type this into my calculator to figure out what my answer is. Now, double check your mode for this thing. These are in degrees. We're not doing stuff in radian. I know it's real gross, but you know, sometimes you got to deal with people who like degrees because they're weird. What are you going to do? Plus, it's goofy to put radians in a non-right triangle. Gosh. Anyway, 30 sine of 105. I like to do my numerator and then hit enter and then divide by my denominator. Divide by, I need sine. I like to do it in these two steps. That's just how I do. So we get 42 point, and I'll round that to 490. I'm going to show you a reason why I actually like to do that in two steps. So through the magic of editing, I've actually typed it all in about in one step in my calculator. So see how I'm doing all of that stuff at the same time? If I do that all at once, I actually get the wrong answer, 13.70. The reason is I didn't put a little parentheses right there. It will work if you put that parentheses there, but it's really easy to miss. And just mentally, it's easier for me to be like, okay, this is my numerator done, take care of the denominator. That's how I do everything else. So I just like to continue that into these problems. So you can do it all at once. It's your call. You're an adult. Do what you want. So now we're going to take care of, so we got A, I'm going to put that in. So 42.490. We still need to figure out what C is, and we're just going to use that same thing. It worked before, so let's do it again. We'll keep using the sine of that angle divided by its side, so 30. Although this time we're going to use a different angle. We're going to use, what other angle? We're going to use that 32 that we got earlier. So sine of 32 over its matching side C. See how this 32 and that C go together. The solving process is going to be the same as the one before it once that angle goes away. So we get C is 30 times the sine of 32 over the sine of 43. Go to my calculator and type that in. We've got 30 sine of 32. I hit enter because I like to do my numerator first. Divided by the sine of 43. And we get 23.310. These are all going to spit out real gross answers like this. We're not going to get pretty things. Assume this whole chapter, we're going to get gross decimally garbage. If you get something that's not gross decimally garbage, double check it. Maybe you did something wrong. Or sometimes it is nice, but assume it will be gross decimally garbage. Yep. I'm going to do one more. This one I'm going to kind of like use edits in order to kind of zip through it a little faster because it is about the same length. It's the same process as the one before, but it is nice to kind of talk through another example at least. So the first thing that I need to do is I need to find this angle. So I'm going to use the idea of there's 180 degrees. So there it is. I've got 35 degrees. I subtracted the two angles that I knew from 180 degrees. I've got two angles subtracted from 180. Next, I need to identify my key. What is an angle and a matching side? So I've got this angle right here and its matching side. That's going to be my key to get the other two. To find the other two, you pick one. I'm going to start with B, so I'm going to set up a proportion for me to solve. In that one, I've got an angle over its matching side, 35 degrees and 12, and 85 degrees and B. Since that's an angle and my matching side, I'm all set to solve. Solving steps will be the same as they were in the previous example. And that is our B, 20.842. Now we have one more side to find for our triangle. Don't be tempted to use the Pythagorean theorem. We cannot use the Pythagorean theorem in these problems since these aren't right triangles. The Pythagorean theorem is very strict. It only works in right triangles. So we're going to set up a proportion. I'm going to do that with you. Sine of 35 over 12. It worked before. There's no reason we should stop using it if we can. Equals, the thing we're looking for right now is C. So we need C's matching angle. C goes with this angle up here, 60 degrees. So we'll do the sine of 60 degrees. All that's left to do now is solve this, which is easy as that. We've got 18.118. So we just type that onto a calculator, same solving steps as before. I've got one more example that I want to show you, and this one I won't be doing any fancy editing magic tricks because it does follow a slightly different process than the other ones. So in this problem, we know two of our sides, so we've already got an angle on our matching side, so we're real excited about that. However, we do not know what that third angle is. Normally in the other ones, our first step was to find the missing angle. Well, I don't really know what these two other angles are. We can use the law of sines to find missing angles. I've got my golden ticket. I've got a side and a matching angle. So that's ace. So I put it into my law of sines. So I got sine of 10 degrees over 4.5. Now, the only other piece of information that I have is that 3. So I better put it in there. Let's use that. Now, the other things aren't labeled, so I'm going to label them something. This was the first thing we had, so I'm going to call it alpha, and I'll have that be A. This is kind of the second thing we got, so we'll call that B. I'll have this be beta, C, and then we'll use this one for gamma. I like to always use those letters just for consistency's sake, but you can use other letters if you want. Don't matter. So the thing that we're looking for now is B, our beta. So we need the sine of beta, which is going to be a little bit different process for us to solve. We need to get that beta by itself. So I'm going to do that similar thing from before. I got to get rid of that divide by 3. So I'm going to multiply both sides by 3. So we get 3 sine of 10 degrees over 4.5 equals the sine of beta. Now I need to get rid of that sine beta. And you know what? Just to make my life simple, I'm going to simplify all of that, get that thing turned into a decimal. I'm going to get a gross decimal at the end anyway, so might as well just do it right now. So 3 sine of 10 divided by 4.5. And I get 0.116. Sorry for an extra decimal there. Okay. Now I need to get rid of sine, and so we need that operation that undoes sine. The operation that undoes sine is inverse sine, so we need to do the inverse sine of both sides here. So we get inverse sine of 0.116 equals our beta. So I need second inverse sine of, and I'm just going to use second answer because I just need to use the same thing I had before. If you type in 0.116, you'll get a good answer too, but it'll just be rounded slightly different potentially, but it's no big deal. So I get 6.48. So B is approximately 6.648. All right, degrees. Now that I know those 2 degrees, I can use these 2 to find gamma, which is a very similar process to what we did before. Gamma is going to be 180 degrees minus the 10 degrees that we started with, minus the 6.648 degrees that we just got. You plug that into your calculator, not super exciting, not worth our time, but I do have my answer key in front of me, so I'm going to get 63.352. Got to make sure I'm getting the right answers. Keep me honest. 63.352 degrees. All right. Last thing we need is we need to figure out what C is. And to figure out what C is, we have to use the law of sines. No Pythagorean theorem. So we're going to use that same key, our same golden ticket. The sine of 10 degrees over 4.5. It worked before. No reason to stop using it now. We have an angle now that we can put into it, the sine of 163.352 divided by whatever C is. You should know the solving process by now. We should see that pretty quickly. We get 4.5 sine of 163.352 divided by sine of 10. We type that into our calculator. Again, super boring stuff. Hopefully you've got the process of typing into your calculator by now. You get 7.424. And you're set. And that's using the law of sines. Once you've got an angle and a matching side, you're set. You've got the law of sines. You can do whatever you want. You can find anything, as long as you have one more piece of information on top of that. But then use those pieces of information to figure out bit by bit where you need to go. That's it. That's the law of sines. That's how it works. Next time, we're going to be checking out the law of cosines, which is also exciting. Well, it looks a little weirder. Thanks for watching.